Assalamualaikum warahmatullahi wabarakatuh. My name is Dhea Anisah Putri. In this occasion, I would like to present you a paper about a local instructional theory for learning the concept of finding the formula for the nth term of an arithmetic sequence through Pocah Piring game. This paper is written by Dhea Anisah Putri, Zulkardi, Susanti, and Meryansumayeka. The first one, I will explain you about introduction and method. For the background of this study, based on Jupri 2022, there is a gap between students' personal knowledge and the abstract formal mathematical knowledge that must be acquired, and the disparity between students' thinking perspectives, including in arithmetic sequence materials. And the second one, based on Mangalep et al. 2023 and Quintero and Rosario 2016, mathematics instruction must emerge from contexts that are meaningful to students and build on their informal knowledge into formal knowledge. And based on previous research, such as Jupri et al. 2022, etc., we know that the RMA approach has been shown to significantly improve students' cognitive processes in understanding mathematical concepts, particularly arithmetic sequence. And the last one, based on Ginting and Rahmawati 2024, using game in mathematics instruction will make students become more enthusiastic and motivated to learn, leading to improved academic performance. Those four backgrounds lead us to the purposes of the study. The study aims to purposely adopting the traditional game Pocah Piring to create a local instructional theory for learning the concept of finding the formula for the nth term of arithmetic sequence and using the realistic mathematics education approach. The study using educational design research with type of validation study and conducted in SMP Negeri 17 Palembang with age grade students. This the step taken in this research using repeated cycles starting from preliminary design, including literature review, designing hypothetical learning trajectory and learning activities based on the learning objective, and validation process with expert, teacher, and lecturer, and focus group discussion. The next step is teaching experiment, including pilot experiment and teaching experiment. And the last step is retrospective analysis, starting from analyzing the data, reflection, finding interpretation, and developing local instructional theory. The result of this study is the first one for the preliminary design. During this phase, we engage the discussion between the teacher and the lecturer, and we find out the relationship between learning stage, learning activities, and basic concepts. This is starting from situational. The next one is model 4, and the last one is formal mathematics. For the situational one, the learning stages is linking students' experience of traditional game Pocah Piring as the starting point of learning. In this stage, we make students share their experience and understanding about the game. For model of, we apply Pocah Piring game in order to make students recognize that the problem was about finding a pattern. And in this stage, they will work on activity 1. And in this activity, they will identify a pattern from the number of stones arranged in the game. And this activity will lead them to the concept of number pattern. After that, in model 4, we stimulate students to be able to evaluate their own models in computing the number of stones at each level to identify the differences. And in this stage, they work on the activity 2, and they identify the number of stones, they determine the difference between the number of the adjacent stone, and they find the number of stone needed if the game is played in the 14th round. And these activities leads them to concept of arithmetic sequences. And in the last stage, in formal mathematics, students work together and each of student determines the formula by calculating the number of stone in the 60th stage. And in this stage, they work on activity 2 and 3, and they will find the number of stone needed if the game is played in the 60th round and identify the formula and apply the formula. This activity will lead them to the basic concept of formula of the nth term of arithmetic sequences. The next one, the design of hypothetical learning trajectory. The student worksheet aims to understand the concept of nth-term formula in arithmetic sequence. There are three activities. The first activity is a glimpse of number patterns. The conjecture of students' thinking is students can identify whether the number of stones piles in each round form a number pattern and provide reason about their statements. For the activity 2, there are four questions. For question 1, find the number of stones in each round. The conjecture of students' thinking is students can find out the number of stones in each round. For the question 2, find the difference between the two piles of stone from adjacent round. In this question, the conjecture is students can identify the concept of difference. They can provide a generalization of the difference formula in arithmetic sequence that they have found. In the question 3, find the number of 14 stones. The conjecture of students' thinking is students can find the number of stones used in the 14th round and they can reason and model the problems into mathematical models. In the question 4, find the number of the 60 stones. The conjecture of students' thinking is students can provide mathematical modeling of problems using their reasoning skill and manipulate simple algebraic calculation and provide conclusion from their finding on the formula. In the last activity, in activity 3, applying the formula to a real-world problem, the conjecture of students' thinking is students can understand the concept of the nth-term formula of arithmetic sequence, and they can use it to solve real-world problems. The next one, this is the result of design experiment. For the activity 1, a glimpse of number pattern. In this activity, the goal is students can identify and understand the concept of number square. So we ask them, after you have done the activity, does the number of stones in activity 1 form a pattern? State your reason. And the students said, yes. The number of stones in activity 1 form a pattern because the stones are arranged according to a rule or pattern, namely a consistent addition rule between each image. And we can see here that when we ask them to continue the following numbers, find the next three numbers, di sini students can answer us by 2, 4, 6, 8, 10, 12, 14. Saya menuliskan kalau ini tuh tambah 2, tambah 2, tambah 2, tambah 2, dan seterusnya. The next one is activity 2, question 1. Find the number of stones in each round. Through this activity, we can see here that student can determine the pattern in the number of stones in each round by counting the number of stones. This understanding leads them to know the concept of difference, which will be asked in the next question. The next one is activity 2, question 2. Find difference between two stones from adjacent round. We can see here that in this round, we ask students to determine the difference in the number of stones used in each round of the Pocah Piring game. And we ask them to write their generalization of difference formula in arithmetic sequence. Dan dari jawaban siswa, kita bisa melihat bahwa siswa mengetahui bahwa beda itu sama dengan babak kedua kurang babak ke-1, sama dengan 5 batu kurang 3 batu, sama dengan 2 batu. Dan hal itu berlaku sama untuk semua babak, sehingga mereka bisa menggeneralisasi bahwa karena barisan di atas memiliki beda yang sama, dapat dinyatakan dengan beda sama dengan jumlah batu pada babak selanjutnya kurang jumlah batu pada babak sebelumnya. And meskipun mereka tidak dapat menuliskan the formula yang B sama dengan UN kurang 1, we can conclude that they understand about the difference formula in arithmetic sequence. The next one is activity 2, question 3. Find the number of the 14th round. In this activity, students are required to calculate how many stones were used in the 14th round of Pocah Piring game. And we ask them to write their calculation method that they use to solve the problem. And we expect them to provide calculation that lead to the formula of the nth-term of arithmetic sequence. Nah, di sini kita bisa melihat bahwa siswa dapat menuliskan babak ke-1 sama dengan 3, babak kedua sama dengan 5, sama dengan 3 tambah 2. Kemudian begitu seterusnya sampai babak ke-14. Nah, dari perhitungan siswa ini, we know that students understand the concept of difference formula in arithmetic sequence. That's why mereka menuliskan 3 tambah 2 untuk babak kedua, babak ketiga 3 tambah 2 tambah 2, babak keempat 3 tambah 2 tambah 2 tambah 2 sebanyak 3 kali duanya. Dan mereka bisa menuliskannya menjadi 3 tambah 3 kali 2 untuk babak ke-4. Dan begitu seterusnya sampai babak ke-14. That's why they can they can find out the answer. The number of stones in 14 round is 29 stones. So by adding 2n times, students will obtain a mathematical model that aligns with the solution of the problem. Activity 2, question 4. Find the number of the 60 stones. In this question, students are asked to determine how many stones there are in the 60 stage. And by providing a fairly large number that would take a long time to calculate manually without a formula, this question aims to test them how to calculate it without using their manual calculation before in the question 3. So we hope that they will able to generalize their calculation, which will enable them to determine the nth-term formula of arithmetic sequence. And we can see here the result dari gambar, bahwa karena mereka sudah mengetahui kalau ronde ke-13 atau babak ke-13 itu sama dengan 3 tambah 12 kali 2 sama dengan 27. Untuk babak ke-14 juga 3 tambah 13 kali 2 sama dengan 29. They can generalize it menjadi jumlah batu pada babak ke-60 sama dengan jumlah batu pada babak pertama tambah babak kurang 1 kali beda. Jadi 3 tambah 59 kali 2 sama dengan 121 batu. Nah, dari sini mereka bisa menggeneralisasi rumus itu menjadi suku ke-1 sama dengan U1 sama dengan U1 tambah 0 kali B, suku kedua itu U2 sama dengan U1 tambah 1 kali B, seterusnya hingga suku ke N. Sehingga ketika ditanya rumus suku ke N pada barisan aritmatika, mereka dapat menjawab UN sama dengan U1 tambah N kurang 1 kali B. So with this one, we can see here that students understand the concept of the nth-term formula of arithmetic sequence. The next one is activity 3, applying the formula to a real-world problem. Now, in this last activity, we ask students to apply the formula they have found previously to solve the real problems. In this activity, we hope that students will be able to not only understand the concept of nth-term formula in arithmetic sequence, but also they can solve real-world problem related to arithmetic sequence. We can see here, students can also apply the formula that have been obtained and solve the given problem. Now, by solving this problem, we can show that students understand the concept of the nth-term formula in arithmetic sequence and be able to solve them in real-world problem. The next one is discussion. In this discussion part, we will explain you about the result of retrospective analysis. We have iceberg here, and after conducted the second phase, it is shown that students' way of thinking in modeling the problem into mathematical formula undergoes a horizontal mathematization process by providing the nth-term formula, which involves various symbols such as U1, UN, and B. And we can see here, this is the result of iceberg from the situational, model of, model for, and formal mathematics. It is evident that for gaining the learning objective as students understand the concept of nth-term formula in arithmetic sequence, we as the teacher should start it with contexts that are real to students and make them understand the difference first. Yeah, after they understand the difference concept of arithmetic sequence, challenge them with a smaller number first. Like us before, we challenge them to calculate how many stones needed in the 14th round, and after they do that, we challenge them with bigger number like 60, so that they can use their mathematical reasoning in finding the formula. As on the research, the local instructional theories prediction about the students' thinking were true, and allowing teachers to employ well-prepared probing questions to help students achieve their learning objectives. And according to earlier research, like Fauzan et al. 2020, Jupri et al. 2020, and etc., the local instructional theory was particularly beneficial in encouraging students to reinvent mathematical idea, and this result support those findings. The next one, the conclusion. A learning trajectory can be produced by using the traditional game Pocah Piring as the background, since it can help students grab the concept of finding the nth-term in arithmetic sequence. The research step, including preliminary design experiment, and retrospective analysis, can verify the validity of the local instructional theory. Three learning activities were applied to the arithmetic sequence content to accomplish the learning objectives. Students' way of thinking in understanding the concept of the nth-term formula in arithmetic sequence can be illustrated when they work on activity. It will help teachers develop learning activities that are appropriate for their students. By conducting the local instructional theory in this research, teachers can utilize the hypothetical learning trajectory, which is based on RMA, and use valid arithmetic sequence material as a guide when implementing learning and creating other learning flows. The fact that this study was only tested in one school limits its applicability, and further research can conduct similar research with trials in various schools with diverse conditions and background of students. I think that's all for my presentation about this paper. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.